Hello, everyone. This is Elisa Baum. I'm GridGain Systems Senior Director of Product Marketing. We'll begin in just a moment, but first I'd like to conduct a bit of housekeeping. First, could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me okay. I'd like to do a sound check to make sure everyone is hearing us. So let me see. Thank you. I see lots of hands. That's good news. Next, during this webinar, you will be on mute, but should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of this webinar, we'll make time to answer as many questions as possible. And in addition, I'll make sure that each of you receive a link to the recording and the slides within 48 hours. So I'd like to introduce today's speaker. It's Rob Meyer. He's GridGain Systems Head of Outbound Product Management, and he'll be presenting the third presentation in our in-memory computing best practices. This one is called Developing New Apps, Channels, and APIs. And with that said, I'll turn the floor over to Rob. Go ahead, Rob.
Thanks, Elisa. Can you hear me?
I can hear you. Can you speak up just a tad?
I will always try to do that. So as Elisa said, I'm Rob Meyer. I've been doing this kind of middleware stuff for a very long time, and I spent a reasonable chunk of my life on API management. So now that I've been working on in-memory computing for a good year now, it seemed to make sense, given that we were getting into a lot of these projects, to talk about using in-memory computing for building out new apps, APIs, and analytics. So there is one thing I wanted to point out, and you're going to see this theme recurring a few times. With in-memory computing, there are really two sides to the same speed and scale coin. In the last webinar, we talked about adding speed and scale to existing apps. You do that by sliding in between the app and its underlying database. Those existing apps are usually getting overloaded by new apps or APIs or some kind of channel overloading it. And so in this webinar, we're going to talk about adding speed and scale above those existing apps with the new apps co-located with the APIs. And you're going to be making that trade-off project by project, where and when you think you need to add in-memory computing. As you think about this type of project or any project, you'll need to think about how it fits into your overall roadmap. You will have to decide where and when to use in-memory computing. It is very rare that two companies follow exactly the same path and make the same decisions, but most companies are heading towards the same destination, which is getting to a real-time business with in-memory computing holding pretty much all of the real-time data about the business. So the destination should be roughly the same. You just have to keep in mind how you get there. I should remind everyone first, and I constantly remind myself about this, even if I'm in the weeds talking to a customer. You're going to design any kind of project like this around the customer experience. The principles you apply during each type of project, whether it's an existing app or a new one, are very similar. So I'm going to be going through a couple of best practices I've gone through before. I went through in the first webinar, which is building the foundation. But what I do over time, what I want to do here is keep expanding on some of these best practices in the context of the project we're talking about, in this case, around API management. Now, the interesting thing about if you've been in IT for a while, and if you've been in it for a while, you generally don't like to admit how many years it's been. But for the last 20 years, we've generally seen 20% of an IT budget being spent on the new, and 80% being spent on just on keeping the lights on. And here we are in a situation where 40% of an IT budget is now going towards something called digital transformation or digital business. That is a big change. And they must be cutting other things to make this a reality. It also means they must be investing as a company. Each company is investing a lot more into IT. The question is why? And we've answered this before, but I want to remind everyone. This is arguably the biggest initiative in most companies I talk to, and is probably the biggest initiative in your company. It's around improving the customer experience by adding some kind of new digital channels or adding some kind of automation, the way folks like Amazon and others are doing it. It's so big because the returns are bigger than for any other part of the business or for any other initiative that can be done. Just to point out one of the studies, Harvard Business School did a study where they compared the top 25% of enterprises who they rated as digital leaders. They had various ways of rating them versus the digital laggards. There was about a 50% difference in profitability, in gross margin, and in what they call EBITDA, which is earnings before taxes, and depreciation and amortization, and net income after taxes. In fact, you should realize it's much bigger than this because even the top 25% aren't reaping all the benefits. This is something that can, over 5 or 10 years, double revenues and more than double profits. And there's a whole math behind that we went through in the first webinar. But the point is that's bigger than the entire IT budget. In other words, we're willing to spend as a company 40% of our IT budget on this because the return is so much greater. This is what ING has discovered. It's interesting to look at ING as an example of a company that's aligned from the CEO down as being focused on digital business to improve the customer experience. This is about being a tech company that's being able to use digital business to deliver that greater experience. It is rare in our history to see a CEO of a big bank like this so focused on a particular technology trend. But the threat of an Apple Pay, a PayPal, or a purely digital bank is very real for most banks at this point. There are also regulations in Europe called Payment Service Directive 2, PSD2, which requires banks to open themselves up via APIs, which is a potential race to commoditization as a player like a PayPal sits on top of different banks and becomes the new banking service for a customer. So unless a bank figures this out from the CEO down, this could be an extinction event for them. It's a do or die kind of proposition for these banks. They have to build up these APIs, making themselves different. They have to use their ecosystem and other technologies around to deliver a better service, to be different for their customers, or they're going to lose them. Excuse me. So Levin Merks, who's a seasoned architect over at ING, did a great session. We've talked about it a little bit before. But he did a great session on API management in retail banking at the In-Memory Computing Summit. If you haven't visited the In-Memory Computing Summit site yet, you should. There are all kinds of webinars from good, solid practitioners on all kinds of topics. So if you're looking for something and want to hear it from a company, from a peer, you're probably going to find something there. If you're in London in June, if you come out to San Francisco in November, you can join one of these summits. You should be reaching out to us and letting us know. Levin worked on integration in SOA back in the day before API management and has been in middleware for a while. So he's seen a lot of different evolutions of middleware and has a lot of good lessons. But whether it's Levin or whether it's David Fallon, another good practitioner over at ING, or others, you'll see from the CEO down, they're all focused on improving the customer experience, on creating this frictionless experience across channels. That is an advantage for a bank, just so you understand a little bit of the context. The banks have multiple channels because customers want them. These big banks that have a combination of brick and mortar and digital spend almost 2 times as much, the customers spend almost 2 times as much as they would in a brick and mortar only or a digital only bank. That also actually applies across other industries. We all love Amazon unless we compete against them. But we all want to see some products and touch them before we buy them. That's why Amazon's been buying into retail. And that is an advantage for companies that are already in the retail business, that they have these channels and this customer experience. Digital business is all about leveraging that and combining it. So the first practice is really make sure you in your projects are also focused on the customer experience that you designed around it. If you aren't somehow in sync with a chief customer officer or someone who's responsible for the customer and their experience, if you don't have a process architect, if you don't have a data architect or aren't working with the data governance team inside your company, you should be asking yourself why. And we'll go through in more detail why that's so important. You should also have an API product manager because that is the person who's designing the product called the API that's consumed by outside developers in your ecosystem. You should be treating it as a product from the outside in. It's not like your typical IT project. If you don't have one, you probably have a problem. You need to find someone who's responsible for designing that API. You are going to think about designing your processes and APIs around the customer, so it's a top-down exercise, and that's what your API architecture should look like. And you should be layering your APIs. We'll talk a little bit about this more, about public and private APIs or microservices, and how you also think about the process. And you're going to make sure that there are many different practices you have. You're going to push things into your APIs. There are more around analytics and automation, so your APIs do need to be extensible. The first best practices beyond just focusing on the customer, really around the fact that you're going to be building a new real-time layer on top of your existing systems. And we already talked about this bit in the first series, the first webinar in the series. I want to expand on it more and explain what it really means. So over the years, I'd say I've talked to hundreds of companies about API management on specific projects, a lot of banks, and probably spoken to thousands thinking about it. Several of them were actually companies I've worked with in previous corporate lives on SOA and integration, like IMG. The basic principles, the goals of API management can be explained pretty simply. You're just trying to become API first, meaning to get to a point where you're delivering an API, a public contract that someone consumes, that you've designed from the outside in. And in order to succeed with becoming API first, you need to be able to open up your existing systems as APIs from the outside in. Easily said, not so easily done. You need to be able to do it in days, just like the PayPals, the Apple Pays, and especially the smaller companies, not in the months that it takes you to release changes in your existing apps, your CRM apps, or the months or years it takes to change your existing system of record like a mainframe. This has to happen in days, maybe weeks. And you need to focus on improving the end experience. That means not just building APIs. That means actually there's a lot of new functionality you need to add that gives you real-time intelligence to what's going on with a customer or a product shipment, and takes that analytics and automates it, not just to help you streamline the process, to give you fewer steps in the process with a customer, like a one-click order. You also actually have to be watching what's going on with the customer. And when something goes wrong, you need to be able to recover really fast, because that's how you retain that customer. And that's in the math. That's part of the math behind customer retention that we went through a little bit in the first webinar. So this part of the analytics and decision automation might come after you do your basic APIs, because the first step of the experience is actually just giving a better structured process, giving a more streamlined process, not necessarily automating it intelligently, but you need to keep in mind that you're going to need to add the analytics and the automation. Now, there's a problem in most companies with becoming API first, and it's really that most companies end up being existing systems first. So the reasons are, first, an API or opening up your business typically adds 10 to up to 1,000 times scale it puts a much bigger load on your existing systems. We search 100 times before we book a hotel room or buy a product now. Those queries are 100 times more queries than before. We do smaller, more frequent purchases, like what we do on Amazon versus what we do when we go to a supermarket or Costco. So we also expect this to happen really fast on the website. We don't like to wait. And so that's what I mean by an increase in speed and scale. The second challenge is developers have to wait a long time to get access to any new data that they want to use for APIs. And the reason is because, well, existing applications are locked down. The data we were used to having data just entirely behind a firewall and protected by the application layers. We're kind of going around that now. We're violating the principles of those existing apps. As a result, everything's locked down. Everything has to get approved. These are good reasons because the applications really aren't protected adequately. You have to figure out how to put in place a layer that API developers can consume where all that protection is already there. And the third reason is if you're really trying to do analytics or automation, one of the big issues is the data you're doing it against, it's stale. It's outdated because analytics has been split off from transactions for probably 3 decades now. And so you have to figure out how to merge them back together to get back to a real-time view of the business, real-time data, and an ability to perform the analytics on top of them without impacting how the data is being used in transactional apps. You may think that some of these issues, like an increase in speed and scale, are not, you don't have that issue, that your APIs are working fine. And now, if you believe that, either you figured it out, in which case you really should be giving the next webinar, because we really do need to know how to succeed there, or you haven't reached broad adoption of your APIs, which is more common, or most commonly, you've accepted the limitations, and we do this all the time. Think about some of the features you have that make some of the products we use in API management or middleware great. So think about API throttling. This is a great one. This limits how many times an API can be used by a user, a company, or as an API in total. It's a great feature that you can limit APIs because it limits the load you put on your existing systems. The problem is, so it protects mainframe from going down, it protects existing systems from becoming too slow, but that's really an existing systems first strategy. It's at the expense of the API and the consumer using it. And the way I would put it is, would you really want to be limited by an API that suddenly told you, I'm sorry, you cannot use me, if you were consuming that API, and would you trust it? If there was a better API or service that you could use at any time, you'd probably move to that other API, and that's the challenge. You need to be able to deliver the speed and scale that people are expecting when you provide an API. The second is underneath, the API throttling actually comes from flow control and middleware, from messaging and application integration systems, where you used to point a finger at the middleware when the mainframe went down because the middleware was in the middle, creating the load. TIBCO, EMS has it, some other systems have it. You basically smooth out the loads by queuing up requests in queues in your messaging infrastructure. Now, it's okay when you're trying to save a mainframe and you have no other choice. The challenge is, because these things all exist there, you actually have no idea when it hits the system as you increase the load on your system. So at some point, as your API loads increase, and they will increase, you have no idea that this bottleneck exists until it happens, and you start violating SLAs without any way of compensating for it, other than dialing up your API throttling. So the point is, again, you need to be able to support the speed and scale people are expecting. The third limit is usually around databases that they're only scale up and not scale out, so it becomes increasingly expensive to scale it up. And at some point, you hit the wall. At some point, you have to go scale out horizontally. So you have to be able to do the math here and look ahead and figure out when, not if, you hit that wall, you hit the limit at speed and scale. We'll talk about the math a little bit later. So if you limit how much that API can be consumed, just to summarize, the chances are the limitations are only going to get worse. You just need to do the math and figure out when. In the second area, the second challenge here is really it takes too long to add data to new APIs. And we talked about a little bit, it's partly because these apps they're assuming a firewall is around them. They're assuming there's some kind of protection. The second you add an API or integrate a single cloud application into your existing systems, you have violated that premise. There is no longer a firewall when there's a REST API that punches right through that wall. So by default, it means you have to assume the worst and the data needs to be locked down. So you need an architecture that supports that. Second, the second you open up an API, you potentially put a really big load on existing systems, in particular existing databases, because the applications often can scale better than the database. It takes time to add scale to those systems. You're either creating some kind of offload or you're buying new hardware. So you have to wait. It's also true if you have to make any changes to those apps or the databases, that's the long release schedule, months. At the very least, there's a whole traditional release cycle you have to go through. You have to wait for the hardware. So it just takes too long. And fourth, even if you figure this out for one system, the data is generally not in one system. If you've ever built an API, it is by design very different from a web service. They're surprisingly flat. You have one API for a customer, one API for an account. That's generally merging data from many different systems and creating a simplified view of the customer or the account. And if you have ever tried federated queries or joins, meaning grabbing the data over the network, figuring out how to merge it together, and then present it as a single view, is just too slow. You really don't have the time. The third challenge is that OLAP and OLTP, or transactions or analytics, are separated. And that's because for the last 30 years, people hadn't structured the apps to do analytics, and putting the additional load was just too much. It wasn't worth it. So people said, well, we'll wait. We'll allow the data to go stale, because that way we can grab data from the 30 or 40 or hundreds of different apps we have that were started by each different group in the organization to solve their own point problem, suck all the data out using ETL, reassemble it into a single view of the business, and then cleanse the data because the data is inconsistent, it's dirty, and pull it all together and magically come up with a single view of the business that's minutes or hours or days out of date. And that was okay. That's no longer okay, because now we need to do real-time analytics. We cannot have stale data. We cannot spend all that time pulling the data together. So something has to change. And so we need to move from this traditional ETL separate pipeline to something that some people are calling HTAP. Gartner calls it hybrid transactional analytical processing, or HTAP. They coined the phrase. 451 calls it HOPE, hybrid operational analytical processing. It's really more about operations or interactions, what we're talking about here, not just the transactions. You're trying to improve the overall experience. So I partly like the term better for that reason. I also partly like it better because I like hope. I always like to have hope. But whatever you call it, it's needed. You need a foundation somehow that can both do the transactions and the analytics, because you need a real-time view of the data. You need to be able to perform the analytics in process really fast against the data as that interaction is happening. And so it's a very different beast. These three reasons combined, especially the fact that you can't do HTAP against your existing transactional systems or your OLAP, means you probably need a new layer with your APIs to make this a reality. Now, what most companies have figured out as they've been doing API management and hitting scale, they found some solution with in-memory computing co-located with their APIs. So they've built out a new data layer with their API layer, co-located with their API layer, that for speed moves the data into memory in locally on the box where the API is running. For scale, they've figured out how to scale horizontally, elastically with each API. So as they bring up a new API, they bring up a new instance of the data locally in memory. It's the same DevOps infrastructure for speed, for agility, for speed of deployment. If it were a separate DevOps environment, they really couldn't roll things out as quickly. And it's an extensible data layer, meaning they can plug other things in over time and run it against the same data to do things like real-time analytics and machine learning. So they built out some kind of in-memory computing layer, no matter what technology they're using, to be able to do those four things. The part of the reason GridGain looks the way it does as an in-memory computing platform is because projects like API management have shaped it to be that. These companies have needed the ability to merge data from many sources, combine it into a single view of that combined data, and have it be consumed by an API or have it be consumed by some kind of compute to perform analytics or machine or deep learning. And that typically requires something like an in-memory data grid. To be able to ingest all the new data that's needed for analyzing interactions or IoT streaming data, for example, or to scale transactions horizontally, they've typically needed a scale-out in-memory database. They've also needed to be able to ingest streams in real time and process those streams in real time. So they've needed support for streaming analytics. And because the data is so big that they want to use to train models, they can't move it over the network. So to do continuous machine and deep learning, to continuously improve models that they're using to help automate decisions, they have to be able to push not just the analytics, but the machine and deep learning algorithms directly to the data and run it in place, in memory, at scale. And so this has forced the consolidation of what were previously different in-memory computing technologies into a single platform, a single cluster that can do all these things. Now, I did want to make a distinction about when I use the term GridGain and I use Apache Ignite. For my purposes, when I talk about it, they're the same. Functionally, they're the same. Meaning, Ignite provides the core in-memory computing platform that's inside GridGain. It's the ability to act as an in-memory data grid and database to support streaming analytics and machine and deep learning, all from the same cluster, the same platform. That's what Ignite does. It helps you unlock all that data and use it together across projects. So what GridGain adds is the security, the deployment, monitoring, and management tooling that allows people to, with comfort, with confidence, take Ignite into production, or a business critical app that can never go down, or to manage a distributed database in production. All that tooling is actually in GridGain. A lot of it is not actually part of Ignite. Now, there are many large Ignite deployments in production. It's not to say it can't be done. It's just to say that GridGain makes it easier and also adds some monitoring, some metrics that allow people to have better visibility into a deployment, which helps them increase availability. It also adds all the bug fixes and hot patches that people expect. But the core is the same. So I'm going to use GridGain and Ignite interchangeably here unless I'm referring to an actual deployment that's using GridGain or Ignite. This is generally how GridGain Ignite is used with APIs. The most common approach that people use is as phase one is you're going to see clusters brought up that are a combination of APIs and GridGain nodes, which are the basic compute unit in a GridGain or Ignite cluster. You're going to take the API, you're going to take a node, which is an in-memory data store, it has persistence, and it has the computing function, and you're going to co-locate it in the same Docker container. I should add that the majority of deployments we see are now Docker containers, have been for a year or so, maybe 2 years. We're getting to a point where half the deployments are using Kubernetes now, or really half the customers. If you're deploying something that's new, you probably should be asking yourself the question, am I using Docker and Kubernetes, or more importantly, asking yourself the question, if you're not, why am I not using those technologies? You should really have a good reason, because it's becoming the default approach for deploying, especially for deploying APIs for your DevOps infrastructure. You're probably going to be deploying GridGain as part of the API in that infrastructure. When you do that, it makes it a lot easier to scale up elastically. The thing that you figure out is how to deploy the right data to each API using affinity or SQL affinity or some other affinity function, and you'll figure that out. But doing it this way makes elastic scaling and manageability and makes a shorter DevOps cycle possible. Okay, so as you bring it up, as each new API comes up, the node automatically gets added to the underlying in-memory data grid or memory computing cluster. And the node gets initialized, and then together, once the node is initialized, the API is registered as being ready to start handling requests. This is typically what you're going to see. IMG does this, meaning they co-locate, they bundle the node, each node with underneath an API. And they built 2 layers like this. You're typically going to see a set of data services that are public APIs, that are the public contract for the data service, with private services underneath. So you're always going to have 2 layers like this. We'll talk a little bit more about that. And then they have a business services layer as well. The first layer is just for accessing data, holds a lot of logic for how to pull the data together across systems. The second layer is focused on the customer experience. That's the C and the E in ICEP here. That is their business layer. So whereas in-memory computing holds the data within a data service, and the business service in-memory computing is holding the state of the session for the customer, all the information that's needed around the customer during that session. Look at this architecture and do the math about speed and scale. Everybody should be going through this exercise. I've written out some formulas for you for reference, but if you look at the architecture you just saw here with IMG, in order to secure those APIs, to build out the auditing, you're going to have single sign-on, you're going to have some logic associated with security, and by security I mean authentication, authorization, auditing policies, data policies enforced there before you even get to your business services level, APIs, which is before you even get to data services. So you have to do the math on how much time you spend on those 4 network hops and those 4 layers. You have to subtract that from your total acceptable time. Your maximum latency within your mobile app, for example, which is usually less than a second, and say how much time do I have left to for the data service. IMG did this math. It was less than 100 milliseconds. That's what they needed to do a second response time or less every time. They couldn't get below 200 to 300 milliseconds without really good, there's really good middleware. This is a big TIBCO deployment. They're a seasoned shop. They couldn't get low enough, so they had to add something like in-memory computing. With GridGain, they get below 100 milliseconds every time. So first, do the math on speed, how fast you need to be every time. Do the math on storage. How much data do you need to hold? I should say this. Existing data often isn't the problem. The majority of new data you're adding, the majority of your growth is all about interactions, data about the customer, what they're doing, about your network. If you're lucky, that runs into the terabytes. Otherwise, it's petabytes. That's often where people are headed within the next 2 to 5 years. So do the math on how much data you'll need to store. You'll probably find you're going to hit the limit on scaling vertically. And look ahead 2 to 5 years. I would say look ahead 5 years because your architecture needs to last. Now, the other area of scale where the bottleneck, where you'll find a bottleneck is just scaling the APIs. You can't scale the underlying data queries or transactions enough if you're dependent on a scale-up database. So you need to do the math on how many queries you're actually going to be doing and how they're growing over time. Not just to do the searches, but to query to do other things like improve the experience. You're going to be adding all other kinds of analytics and other things on top of that data. Add those in for the math. When are you going to hit that bottleneck? And then there's the final bottleneck, which is the network. How much data do you need to move between a database and the function that you're doing, like the analytics that you're doing, to be successful? How long will it take to move that data? HomeAway VRBO, if you know vacation rental by owner, it's not part of Expedia, just to put up the prices for the houses that we search for in different areas when we're renting a place for vacation, it ended up being 100 gigabytes a second. They had to move 100 gigabytes of data a second to support peak loads. And they were hitting this. They were getting to about 500,000 pricing calculations a second. They needed over 100 gigabytes of data to do those pricing calculations, where they fetched the data from the database, moved it into the pricing calculations on a different box, and ran it. A 10 GE network, which is what we all enjoy if we're lucky at work, most of us, can move a gigabyte per second if we're lucky, if it's fully loaded, no collisions, which pretty much never happens. So it's less than a gigabyte a second. You'd need 100 networks to do that. The only way to do those calculations is to move the code to the node, the code to the data, and run it there. And that's what in-memory computing does when it scales out horizontally. It doesn't just scale out the data, it scales out the compute. And this is what we're getting at when we talk about hybrid transactional analytical processing, and doing not just some standard transactional code, but running analytics. You are going, when you do this math, you're going to be showing that you have to design for HTAP, for co-locating the code with the node. You're either doing that at first by bundling a node with each API, but then eventually for analytics and machine deep learning, which are separate from an API, run at different cycles, at different times, really. They're different. You're going to have to move that code to the node as well. So we'll talk a little bit more about that. I did want to remind you, we talked earlier about this as well, but I wanted to bring it up again in the context of API management. You're going to have to choose the best integration architecture between this new real-time layer you're building and the non-real-time apps, the existing systems that you're building on top of. There are two common approaches that I see, and I call them sync or CDC. Either one is actually good. It's not like sink or swim, where sinking is bad. Sync and CDC are both good. It just depends on what your constraints are. So the way sync works is you slide in memory data grid for both reads and writes. It's a read-through, write-through cache in between the database and the app. If there's a write from another app to the underlying database that doesn't use the in-memory data grid, you're going to have to figure out how to sync them up. If applications are separable, where they're not really writing to the same data at the same time, you're not going to have a lot of collisions. This architecture works well for that. If you need immediate consistency, but there aren't many collisions, this architecture works really well for that. I apologize. I think I'm going to switch to speaker, so hold on one second.
Can you folks still hear me?
Yes, we hear you.
Okay, perfect. So you're going to slide in memory data grid in between each application that you're accelerating. And the in-memory data grid is going to keep them consistent because they're all writing to the same source. The in-memory data grid first then writes to the database. For the applications that don't, like a batch-based mainframe, you're going to have to figure out how to take the changes that get written to the database and somehow sync them back to the in-memory data grid. You're going to do that using some separate integration layer. And this is what, in fact, what 24-Hour Fitness does in their architecture. The good news is this takes work, okay? But the good news is the data within each application attached to the memory data grid is immediately consistent. And once you've integrated all the apps and put them on top of the memory data grid in read-through, write-through pattern, you can simply turn off the synchronization. You're done. The other option is using change data capture and having read paths and write paths be separate. So in this case, you just change the read path to point to the memory data grid, which is fed using change data capture in a read-only pattern. This works when you don't need immediate consistency and also when you don't have control of the other applications. It doesn't work so well when you need immediate consistency, but organizationally, sometimes this just happens. This is the way you have to do it. When you have customers doing this, it's a perfectly fine approach. It's cleaner on the integration side, project by project. However, at the very end, if you ever want to move to immediate consistency, you have to do all the work at once, which is almost impossible for the same organizational reasons that led you to here in the first place. If you do have high collisions across apps, and they're not all writing into the memory data grid, this actually does work a little better as well. So do the math on speed, on transaction scale, on storage, and on network scale. Build a real-time layer on top of in-memory computing, on in-memory computing with your APIs, and integrate between the real-time and the non-real-time using one of those two patterns. That's really, if I had to summarize it in any way, those are the three things I'd summarize. Do your math now to figure out when you're hitting the limit, not if. And then build the real-time layer and build the synchronization depending on what you need. The third best practice is around the reality that you can't just have a hammer and have everything look like a nail. When you build a real-time digital business layer like this, you're actually going to need many tools. You're going to need tools not just around APIs, which are basically tasks. You're going to need to build out real-time data, events, and processes as well. I'd have to say over the last few decades, I've worked on just about every integration competency or religion. And I've learned a few lessons, maybe not enough, but a few. One of them is not to use one approach like API management and ignore the other practices. You're going to need to pull together just about everything to improve the customer experience. That includes business processes because you're streamlining the processes. It includes data. The data needs to be accurate in real time because we can't just take dirty data in because we're going to spit dirty data out really fast and corrupt our systems. So in general, you need to fix the data at the point of entry. That means real-time data quality, real-time master data management to make that happen. You also need to be able to add things in over time, like machine and deep learning for analytics and for automation. So remember what you're trying to accomplish. Look at IMG's example. On top of the existing channels, they actually built out 2 layers of APIs using not just API management, but they built them out to add the speed and scale. And then on top of that, they added a whole bunch of security and compliance. They expose APIs that are part of their business to combine them with APIs that are part of their partners or other places so they can offer new things to the customers. So they need orchestration and cloud integration to assemble things together. They need some kind of processes and event-driven technologies under the covers, not just to walk people through a better streamlined process, but to be able to react when things go wrong. So on top of the existing systems, beyond just building the synchronization and integration, there's a foundation that they build both for the APIs, the contracts, and for the data to create this abstract layer that people can build on in days, that they can add new APIs in days, not months that are required to change the underlying systems. But beyond just the APIs they're building streaming analytics in memory, side by side. This is not going through the APIs. Stream processing and streaming analytics is just different. It's something where you take in a stream, you process it as it happens. It's not about a customer interacting with you in some structured process. And machine and deep learning just happens on the side as well. Against the same data that you're using, you're throwing different compute at it. And so basically you need to be able to scale horizontally to handle all these three loads, but they're all going to be running on the same data. And then on top of this foundation, you're from the customer down, you're building out business processes, you're orchestrating and integrating APIs inside and outside the business, and you're implementing various stages of data governance and data management as you need it. I like to put it up at the top, even though it's foundational, because most people seem to implement data quality and master data management later, when really it should be starting at the beginning. And this always reminds me that, hey, when are you doing data validation of data as it comes in? Because if you bring in data from an API request and it's bad, and you synchronize it with the existing systems, your existing systems are now bad. You need to think of this more like just-in-time manufacturing, where you stop everything, you stop the assembly line as the problem happens. That's what happened when we went from batch manufacturing to just-in-time. It's the same thing. Catch the data problem at the point of entry, fix it, and make sure everything's clean. And so that's actually what people do. And I've seen it in banks, I've seen it in other companies. They actually add in some data validation, even some master data management really early on. But they invest in this over time. ING has been doing this. Their data services have orchestration, they have validation, and they have various other tools for transforming and cleansing the data up front. Their business services have process that are around the experience. They do process orchestration for assembling different private APIs. And they have a way of using existing APIs that are not on this infrastructure, accessing data that's not in the Shield IMG data services when they need it. So they've thought about how the architecture is evolving. They've also looked at some of their projects and thought about what they need to add, in particular, a master data management cache in memory and a validation, a way of validating in memory. Mainframe offloading is a very typical use case here. And what typically happens is they'll layer their data services on top of existing systems like the mainframe and keep the data up to date in memory. They'll commit to in memory first, and then they'll pass the transaction to the mainframe. You can either commit synchronously in in-memory data grid, or you can just fire and forget. As long as you maintain a real-time view of the business in memory, as long as you have a synchronization layer that takes anything that's asynchronous in the mainframe and updates the real-time layer, you can manage these two realities really well. And that's how ING does it. This is how 24-Hour Fitness does it. They have a synchronization layer, but you need the master data management or data validation up front to make sure the data is clean. So I saw another top 20 bank doing this. They're building a master data API that's an API into a master data cache as one of their first projects, because this is a requirement for them. So define your overall real-time architecture up front, and do that by making sure you're aligned with your executive sponsors, the customer, the chief customer officer, the chief business officer, chief data officer, and the architects behind them. Know who's going to help you shape the business process based on the customer experience and drive that down into your APIs. Make sure you have an API product manager who's helping you shape those public APIs that are built on private APIs. And then look at making sure your APIs are extensible. So think about when you're adding in each of these other technologies for real-time data, events, tasks, and processes. You're going to be looking at new technologies, by the way. A common pattern I'm seeing now is what I call KISS. It's not keep it simple, stupid. It's Kafka, Ignite, Spark, and Spring. Spring Boot and Spring Data, which is used for the tasks and some data access. But Spark for the stream processing, Ignite for the data management, and Kafka for the streaming. I'm seeing a lot of that being used together. The second to last practice is free your data. You're going to have to decide when you add data to in-memory computing. And it takes time to add this data in. So you have to look ahead and do it in advance. It's kind of like the Matrix. You can take the red pill and move into your reality now, or you can take the blue pill and wait until you need the red pill later. And both are okay. You can decide to keep your data separate for a while and access it the way IMG accesses it outside of their data services, or you can move it in advance into your in-memory computing layer and make it freely available for any API developer to use. You're going to have to decide in advance based on your trade-offs what makes the most sense. Even in the early days of application integration, we always built common APIs for connectors to translate, to have a generic connector that then was adapted for a specific application, and we had canonical data models that you map to each application-specific data model. It just made the integration a lot easier. And so API management is the same way. Your public APIs, if I look at within API management, your public APIs are your contract with the customer. They never change. They're like a product. It's your commitment. The private APIs do all the integration with the existing systems, and they present something to the public API that the public API can depend on. So if you need to add new functionality, there's some combination of changing generally 1 to 3 private APIs and maybe a little bit inside the public API to make that work. But that double layering is what's helped people keep their public commitment, their contract with the customers and the partners. Same with at the process layer, the API layer, there's usually a canonical API data model of what data looks like across the APIs that's mapped by the private APIs into the various applications. You're going to have both layers in both. You might have an in-memory data grid that slides in between an existing app and a database. That data then gets moved into another cache in your cluster that's transformed into the public API data model. That's how it works. It happens really fast. Once you get once you get it in memory and you allow people to do it this way, they can access the data in days. You can have your governance controls in the data grid, in memory computing, but then you can scale out horizontally and allow them to use that same data with other workloads without impacting the way that data is used with existing workloads with those other nodes. And that's why horizontal scaling is so important. So look ahead for new APIs, what data they need, for new analytics and processing, or HTAP, for future projects, or even just to simplify integration. Look ahead and see whether you need to move data now as you're touching it into the memory data grid or not. And if someone told me that to simplify integration, I could move a tiny bit more data from another app into the new data layer and avoid a whole synchronization layer, I'd do it in a heartbeat. So think about how you simplify your architecture as well. Maybe avoid some synchronization because that's cleaner and that's lower risk. So free your data now when you need to unlock it for future projects that are coming up. If it's better to implement in-memory computing above an existing app for an API, do it that way rather than doing it below the app, because it's two sides of the same speed and scale coin. You're either adding speed and scale to the API or you're adding it underneath the existing application. And then if you do that, it makes it easier to turn on persistence and scale transactions, because your data model transactions are actually supported within the in-memory data grid. You can really just turn that into a database at any time. The final point that I wanted to make is make sure you're layering your APIs and your data models. You're going to have private models and public models. It's that insulation, it's that extra abstraction that allows you to change APIs up above the model in days and rip out underlying applications as you need to without impacting the existing APIs. So that's how you get your agility. The final practice I wanted to go through is just design with hybrid transactional analytical processing, or HOAP, operational analytical processing, in mind. And there are really three shades of HTAP. The first one we talked about, it's bundling each API with an underlying node that holds the data for the API in memory on the same box. That's the traditional API-centric in-process processing for speed and for scale. But there are two others that are more data-centric, that are oriented around the data. The first one is really, I'm going to go backwards. The first one is really a compute grid, where you push the code to the node, the compute to the data, to do things like machine or deep learning, or to do deep analytics that have to run against a massive data set. It cannot run on a node, a single node, where the analytics you're doing are kind of independent of APIs in the first place. And the second is when you need to expose some of this computing as an API, you want to make it really easy to redeploy that API with any changes to the underlying compute. So the API-centric HTAP is really, you're going to bundle an API and a node in a Docker and Kubernetes container. It's going to initialize on startup with the API. And the way you partition the data is just to focus on that API and the data that only that API needs. The compute grid, we have the ability not just to manage data horizontally across a cluster, but to push code to each node, to push Java or .NET or C++ dynamically, and compute against the data in each node, and then aggregate the results over the network. It's kind of like a real-time version of MapReduce. In fact, we support MapReduce, but it's a real-time version of it in memory. And this is how you avoid the network bottleneck where the data is too big to move. If you deploy the code through the compute grid, not through Docker and Kubernetes, you're actually allowing analytics to change at a different speed from your APIs. You're not dependent on your API DevOps cycle to run new analytics. And if you're in the analytics business, you know that you really want to be able to change things quickly and optimize things quickly. So the compute grid allows analytics, machine and deep learning to have a separate DevOps cycle from the APIs, which is important. So if you need this, you're probably using the compute grid to deploy code alongside the data. The service grid just makes it easier to expose that compute functionality as a RESTful API and brings the API specifically for those kinds of compute into the DevOps lifecycle for all the compute grid functionality and for the data co-location, where it's really complicated to co-locate the compute with the data. It's spread out over many nodes. So you can run this as a singleton. You can support singleton patterns to ensure an ordering principle, for example, like in trading transactions. You can also support horizontal scale out, where there's a service on each node or multiple services that you can run for pure scale out. So those are really the three patterns. You're going to have to plan ahead for each type of HTAP you need, meaning running transactions and analytics together and running analytics within the same transaction in process, or just running real-time analytics in general. And you're going to have to think about which mode. Is it just an API-centric piece of code you're running for HTAP, or is it something that has to be oriented around the data that you're going to run? And based on that, you're going to choose how you deploy. As a, in the compute grid, with the service grid, or are you going to deploy using Docker and Kubernetes in your API DevOps cycle? So we've gone through 5 best practices here. Hopefully this has helped. There are really 2 sides for me. API management and building new analytics and apps is kind of the same. You apply the same principles to the new projects as you do to the existing projects that we went through in the last webinar. And just remember that those existing apps are usually getting overloaded by these new apps. So you're going to have to make the trade-off and look ahead and decide what is the best approach for adding speed and scale to existing apps. Is it sliding in between the existing apps in the database, or thinking about investing in adding speed and scale on top of these new APIs? But your end destination should end up being roughly the same as everyone else's. So with that, I think we can take some questions. Coming up next, we're going to make a call on what we think is the most productive conversation or best practice to go through based on where people are, and it could be any one of cloud integration or implementing HTAP or becoming more event and stream driven and implementing streaming analytics. And so we'll figure that out soon and publish it, but I hope this has helped. In the meantime, let's see what kind of questions people have asked. All right, so there's one very specific question about any plan to add foreign key constraints to improve data quality. And the short answer is yes. And feel free to ask any specific roadmap questions. But yes, table constraints are getting added into Ignite. That's on the Ignite roadmap. So that is coming. There's some things that people depend on or expect in databases. And over time, the Ignite community and GridGain in particular has been adding them in, and those are coming. They're coming soon. We will get these slides sent to you over time, probably in the next couple days. But more importantly, we're going to turn this into a best practices white paper as well, so that you can go through this in gory detail. Because I know for me, it takes me a few times to really internalize something. And we think of these best practices and tips and tricks that you refer back to just to remind yourself, okay, how should I think about this type of project? What are the top 5 things I should think about? And what have other customers done? So we want to summarize that as more of an ebook kind of format for explaining how people deal with different problems in each type of project. The other question that comes up a lot, I see it's coming up here, is private APIs and public APIs in the canonical model. So I wanted to go through that again. An API is a public contract. It's a product first. The product is the contract, the API specification. Everybody consumes it. It does not change because you will break people's applications if it changes. So what people discovered over the years, there's some practitioners, there's a guy at Kevin Kahoot over at Accenture, Mark O'Neill, who's now at Gartner, was one of the first to apply this as well. You basically create a public API that is an orchestrated, a combination of private APIs. Any one of the private APIs can change under the covers to allow an application or a piece of functionality to be ripped out and a new one put in. It only impacts that one private API. So that's how you insulate from what's below. If you need to change functionality in a major way, you can change the private APIs without changing the contract between the private and the public API, or change some functionality in the public API, assemble new private APIs into it. The abstraction has been enough that most companies that have done it have been able to not violate the principle of changing the public API contract. So it's been a best practice that's kind of moved forward. What people don't talk about is the data model underneath. That, in fact, the best models have also been a public API model, which looks very different from the web service or the existing data. That's a canonical model, because folks like Levin have at IMG have already practiced this in application integration. They kind of know it. But you need to think about creating a canonical model that is not application specific. It's generic enough that you can map different apps to it, and that as you change the apps, the APIs will not be affected. You don't have to change the data in the API. And that's why you need the canonical model as well. Those are most of the